Hello, today we will solve quiz number 1 on chapter 1 measurement. Okay, so the first question, Q1, is a multiple choice question. So you give the main point, meaning the main detail of calculation, then you circle the right answer. Of course, get full mark. Let's begin. The speed of an object is given by V is square root of B divided by rho, where rho is the density of the object and B is a constant. Question, what is the dimension of B? So we want the dimension of B. You remember what we have to do? So let's write an equation for B. If we say V squared has to be equal to this squared, meaning B divided by rho is, of course, V squared. B is just rho times the speed squared. Now you remember what the dimension of rho. Dimension of rho, which is the density, is the dimension of a mass divided by the dimension of a volume. This is m divided by L cubed. Dimension of V. V is a speed. Be careful. Many students, they confuse V speed and V volume. Dimension of speed is length divided by time. Dimension of a volume is L cubed. So it's different. Great. Now, that means dimension of V squared will be L squared divided by T squared. Now, coming back to my first equation, we know that dimension of B should be the dimension of rho and the dimension of V squared. The dimension of B that I want is the mass divided by L cubed, and dimension of V squared is the length divided by T squared. And you do the calculation, you have a mass, length to the power minus 1, and T to the power minus 2. The length is to the power minus 1. So obviously D is the right answer. You get full mark for giving the derivation. And second question, gold, which has the density of, this is the density of gold, can be pressed into a thin leaf or drawn into a long cylindrical fiber. A sample of gold with mass of 29.34 grams is drawn into a cylindrical fiber of radius 2.5 micrometers. Find the length of the fiber or the height of the fiber. Of course, it's a cylinder. So let me draw a cylinder. This is a cylindrical fiber. It's very long. The radius of the cylinder, I call it R, and it's 2.5 micrometers. So the radius is 2.5 10 to the power minus 6 meters. Micrometer, or micron, is 10 to the power minus 6 meters. The question is, what is the height or the length here of the cylinder? So you know that the density gold is the mass of that gold divided by the volume occupied by that gold. Meaning the volume of the gold is the mass of the gold divided by the density of the gold. So here the volume is the volume of a cylinder. So it's this area here, which is A, which is pi r squared times this length here. The volume of a cylinder is, of course, pi radius of the cylinder square times height or the length. This is the equation I will use to get the length. Of course, length will be mass divided by rho divided by pi r squared. Now you have to put everything in the right units. Now let's go step by step and put everything in the right unit. So the length that I want is the mass that I have, which is 29.34 gram divided by, what is rho? 19.32 gram per centimeter cube times pi r square. R will be 2.5 10 to the power minus 6 squared. And of course, you will have it in meter squared. So what do you notice? Gram and gram will simplify. Now I have centimeter cube here, and I have meter square. So the centimeter cube, I have to put it into meter cube. So 1 centimeter is 10 to the power minus 2 meters. So 1 centimeter cube is 10 to the power minus 6 meter cube. So this centimeter cube here, I will put it on the numerator, and it will be 10 to the power minus 6 meter cube. And you see, meter square and meter cube will cancel, and you will have a meter, which makes sense because I'm looking for a length. Now you take your calculator and you do the calculation. 29.34 times 10 to the power minus 6 divided by 19.32 times pi times 2.5 10 to the power minus 6 squared. So this squared times this squared. And of course, you will have a result of 77,340 meters, which is 77.34 kilometers. Okay? So B is the right answer. And you can see this is a small amount of gold, and the radius is 1 micrometer, very, very thin. Okay? Thinner than one hair. Okay? Thinner than a hair, of course. Much, much thinner than a hair. And if you drone it into a cylinder, you will have this small amount, less than 30 grams of gold, can give you 77 kilometers. Great. So let's go to the next question. So V, the speed of an automobile, is given by this relationship. ABT squared plus BT cubed, where T is the time in seconds, and A and B are constant. I did not say dimensionless constant, I just said constant. And the question is, find the dimension of A and find the dimension of B. So again, don't make the same mistake. V is a speed. So the dimension of V is L T minus 1. Some of you took V as a volume. I did not say that. I said a speed. They got the same answer because things will cancel out. So they were lucky. Yeah, be very careful. The V is a speed. So my equation is this: V is A times B, T squared plus B, T cubed. So this is the equation. So it means that the dimension of V has to be the dimension of this. If I'm adding two terms, that means these terms have the same dimension. Meaning, necessarily, AT squared, ABT squared has the same dimension of BT cubed. Is it clear? We said it many times. An equation, both sides of the equation should have the same dimension. Okay? Dimension of V should be the dimension of everything here. That's the first thing. Then the fact that I'm adding this term and this term here, they have the same dimension. So that's why I have dimension of V, which is L divided by T, would be the dimension of A BT square, which would be the dimension of BT cube. Okay, so the dimension of a product is a product of the dimension. So dimension of BT cube is just dimension of B times T cube. And this has to be equal to the dimension of V, which is LT minus 1. So if I use this side, I can get easily the dimension of B, the L T minus 1 divided by T cube. So this gives you LT to the power minus 4. This is the dimension of B. But that's not the question. I want the dimension of A. So how will I get the dimension of A? Well, I come back to this side of the equation here. I know that LT minus 1, which is the dimension of speed, is the dimension of A times the dimension of B that I already know from here. So I just plug it here. Times the dimension of T squared. Okay? So meaning the dimension of A will be LT minus 1 divided by T squared, this T squared, and this divided by the dimension of B. So if I divide by the dimension of B, I will have L to the power minus 1, T to the power plus 4. Okay? Just from this equation, I get dimension of A. So dimension of A will be what? L will simplify, and I'll have T to the power 4 times T to the power 4 times T to the power minus 3. This just gives you T. So the answer is T, as we said before. Okay, the answer here is T. Let's go to the last problem. So I give you the volume of a swimming pool, 6,500 feet, cubic feet. Okay, this is not 16.5. This is 6,500. If it was 16.5, I would say this dot. I'll put a dot here. Okay, this is 16.5 feet cubed. Okay, but here, this comma means 16,500 feet. Cubic feet, sorry. Okay, now I want to convert it into meter cube. Now let's convert it into meter. Knowing that 1 foot is 12 inches and 1 inch is 2.54 centimeter. And of course, 1 centimeter is 10 to the power minus 2 meters, meaning 1 centimeter cube is 10 to the power minus 6 meter cube. These are the conversion ratio that I know. Okay, let's do it. So we'll have 16,500 times 1 feet cubed. I can use conversion ratios, okay? Straightforward. I just want to show you this. So 1 foot is 12 inch. I'll replace this one by 12 inch. So I'll have times 12 cubed times 1 inch cubed. But remember, 1 inch is 2.54 centimeters. You have to take it cubed. 12 to the power 3 times 2.54 to the power 3 times 1 centimeter cubed. But remember, 1 centimeter cubed is equal to 10 to the power minus 6 meter cubed. So bottom line, I have to take this multiply it by this, multiply it by this, multiply it by 10 to the power minus 6 meter cube. And that will give you 467 meter cube. Okay. You do it, you have full mark, end of the quiz. Thank you.